Hi, we are from Group HG11, so the title of our project is Smart Elderly Walking Stick. Statistics shows that Malaysia's elderly population is increasing, as well as the risk of falls is increasing. So the studies reports that 28 to 35% of the people aged 65 and above experience falls, and it will increase to 32 to 42% for those over 70 years old. As balance and mobility decline with age, many elderly rely on walking sticks to maintain stability, yet falls still occur and reduce their quality of life. At the same time, guardians cannot constantly monitor them during daily activities. Therefore, developing a smart elderly walking stick is crucial to provide additional support, reduce fall risk, and allow caregivers to monitor the elderly's location and respond quickly during emergencies. So a survey had to be done because it is crucial to know either this innovative and assistive device is a necessary or not for the elderly and if it is marketable. So a qualitative method survey had to be done through Google form which consists of 25 respondents with 13 male and 12 females. So the range of age starts from 30 years old and above. So mostly, as you may see from the table, most of them agree and strongly agree to the questions that have been asked. So we could conclude that walking stick is the best assistive device. So the objective is to design a functional connection system between the sensors, microcontroller, and the traditional walking sticks. Then to develop an obstacle detection and remote monitoring system. And lastly, to execute the testing for the functional and performance of the innovative walking stick by acquiring fault detection and location data from the sensors to an easy-to-read interface.
So for this part, scope of work, basically from this overview, we have 5 points. But overall, this project develops a smart walking stick that monitors location, detects obstacles, and identifies faults using IoT technology. It allows Guardian to track the elderly and receive alerts through Telegram. The design suits elderly users in Malaysia and focuses on safety alerts, tracking, and data logging. So that is all for the scope of work. Now we have step analysis, where we focus on the needs and impact for this project. First one for the social, improve elderly safety and independence while reducing family concerns. Next, technological, it enables a real-time monitoring and fast emergency response through smart technology. Another one, economic, which creates a growing market and helps reducing healthcare and emergency costs. For the environmental, it reduces environmental impact by using sustainable materials. And then last one, for the political aspect, which supports preventive healthcare and lowers government medical expenses.
My name is Arvindra and today I will be presenting my IDP group project, the Smart Elderly Walking Stick, by demonstrating our conceptual prototype. First, let's see the circuit design which I created using a cricket designer. Now moving on to my 3D model which I created using AutoCAD. The elderly person height is designed based on typical Malaysian elderly person, around 160 cm. For stick is 80 to 60 centimeter height. And all the electronics, the battery, the ESP32, the ultrasonic and MPU's accelerometer and the GPS model, buzzer and the vibration motor are fitted inside the cane structure. For the ultrasonic sensor, when ultrasonic waves hit the obstacle like a rock, it detects the reflection and warns the user. For the fault detection, the MPU6050 monitor the X, Y, Z axis and any abnormal changes in the angle or acceleration in any direction will trigger the system, helping to identify the fault.
So for our walking stick, the first function is the obstacle detection function. Okay, as the elder grow older, their vision become poor. So this is the best solution for them. Okay, so look at the scenario just now. When the elder didn't notice the obstacle in front, so the ultrasonic sensor will play the role and send a signal to the vibration motor. So vibration motor will alert the elder about this issue. So for the second function right now is the falling detection function. Okay. So if let's say the elder is going to fall right now, so what the system will do is the sensor here, the falling detection sensor here, okay, we immediately send out the falling signal to the buzzer here. Okay, so the buzzer will be turned on right now. Okay, if let's say after a few seconds the elder still haven't stood up, so the buzzer right now will keep sounding to alert the people surrounding to notify this issue. So let's say for example the elder has fallen right now. So the GPS module in the system here, okay, will send out immediately the real-time location and the coordination to the guardian, so that his family can immediately and find the elder easily. Alright, so this is our prototype smart walking stick. So now let's move on to the each component here. Okay. This is our power supply. We use two 3.7 battery, and then behind here there is a ultrasonic sensor used to detect the obstacle in front. Okay. Then this one is the ESP32, which is the main component here. This is the microcontroller for our whole system, and then this one is the buzzer. Okay, for the falling detection notification purpose, and then this is the GPS module. okay, for the real-time location tracking purpose. And then this last component is the ride measure motor, okay, used to alert the user when the obstacle now is in front of the users.
So we hope that our innovative XC device with these three main features will help the elderly to achieve their stability, independency, and safety. Thank you.